Hey learner, welcome back to the deep dive. Today we're going to get visual and explore how to draw arcs and arrows in Python.
Yeah, building on what you already know.
Exactly.
Yeah,
Now that you're getting the hang of grouping objects, making things happen with step events, and, even adding motion, knowing how to create these fundamental shapes can really make your projects pop.
absolutely. And the sources we're looking at today, they lay out a really solid foundation for understanding these elements, starting from the basics.
Right. So our mission, let's say, for this deep dive is to clarify exactly how you can generate and manipulate arcs and arrows in Python.
We'll focus on the key parameters, the things you actually type into the code that give you control over how they look and where they go.
Okay, so let's dive into arcs first. The first thing to kind of wrap your head around is that an arc isn't really a shape all on its own. It's actually like a slice taken from an oval.
Think of it like you draw an invisible oval first, and then the arc is just a piece of its edge.
Yeah, imagine you've got an oval, and you're just carving out a portion of its circumference. Our materials actually showed this pretty well, with a gold oval and then a navy arc kind of laid right on top.
And what's interesting is how the arc function itself connects directly to this idea of the underlying oval. The first parameters you give it, center x, center y, width, and height, are the exact same ones you'd use to draw that full oval.
Oh, right.
So like the example, arc 200, 200, 400, 150, 0, 90, filled navy, those first four numbers. They tell Python, imagine an oval centered at 200, 200, 400 pixels wide, 150 pixels high.
And then the arc is drawn based on that imaginary shape. Makes sense.
Exactly. The arc becomes a segment of that defined oval.
Okay, so that leads us to the other two really important bits for arcs, the start angle and the sweep angle.
Crucial parameters.
Yeah, the start angle tells Python where on the edge of that imaginary oval your arc should begin. Now, this might feel a little different from math class. In Python graphics, 0 degrees isn't to the right, it points straight up. And as the angle number gets bigger, you move clockwise around the oval.
Yeah, that's a key thing to remember. 0 degrees is 12 o'clock on a clock face.
Oh, that's a good way to put it.
Yeah, and then 90 degrees is 3 o'clock, 180 is 6 o'clock, 270 is 9 o'clock. Thinking of it like a clock really helps visualize where that start angle is putting the beginning of your arc.
Totally. Our source even has a little diagram for that, which is handy. It's a common convention in graphics libraries, so it's good to get used to it.
Definitely worth internalizing.
Okay, so that's start angle. Now, the sweep angle is the second part. It defines how far the arc extends, starting from that start angle.
Right. It's like how much of the oval's edge are you actually drawing?
Exactly. The source has these arcs demo #2 examples, which are great. They keep the sweep angle fixed at 90 degrees, so a quarter of the oval, but they change the start angle.
And you can see the quarter oval piece just rotate around the center point.
Yeah, it clearly shows how start angle shifts the position.
And if you're thinking about practical uses, learner, maybe like a loading circle, you could animate the sweep angle from 0 to 360 to show progress.
Oh, that's a perfect example. Yeah, using motion and step events, you already know. And then arcs demo #3 does the opposite. It keeps the start angle the same at 90 degrees, so pointing right like 3 o'clock, but changes the sweep angle.
So the arc always starts at the same spot, but it gets longer or shorter.
Right. It goes from just a tiny curve all the way to almost a full oval, depending on that sweep angle.
It really shows the interplay, between where it starts and how much you draw. Gives you a lot of control.
And the source asks a little question. What if start angle is 360?
Any guesses, learner? Well, it points out 360 is basically the same as 0.
You've gone all the way around.
Yep, back where you started. Just
Yeah.
a technical point, really.
Now, one type of arc you'll probably use a lot is a circular arc, part of a perfect circle.
Makes sense. Very common shape.
And the key thing here is, for a circle, the width and height are the same, right? They both equal the diameter.
Which is twice the radius, of course.
Exactly. So the arcs demo #4 example shows this. There's a gold circle defined with its center and radius.
Like circle 200, 200, 125, fill gold. Radius 125.
Right. And then the navy arc on top uses a width and height of 250.
Double the radius. Arc 200, 200, 250, 250, 250.
Right.
It has to match the circle's diameter to be a true arc of that circle.
So if your circle radius is, say, 50, the arc's width and height must both be 100.
Precisely. That direct link lets you make those nice, perfectly curved parts of a circle.
Okay, so that's the lowdown on arcs. Now let's switch gears to arrows.
Okay.
And here's a bit of a twist. In this graphics library, there isn't like a separate arrow shape you call.
No, it's actually simpler, maybe. You use a regular line shape.
Right, just a standard line, which you probably know how to draw already. You give it start coordinates and end coordinates.
And then you add arrowheads using special properties.
Right.
Arrow start and arrow end.
Yeah, and it's pretty straightforward what they do. If you set arrow start,
You get an arrowhead at the start point of the line, the first coordinates you listed.
an arrow in true puts 1 at the end point, the second coordinates.
And you could use both, obviously, for a double-headed arrow.
Yep. The arrows demo in the source shows all these combos. No arrowheads, start only, end only, both. It's quite clear.
But this brings up something important, learner. Think about drawing a line from point A to point B.
Okay.
If you set arrow start true, the arrowhead's at A. But what if you define the line from B to A and still use arrow start true?
Ah, interesting point. Does the arrowhead stay at A or move to B?
It moves to B. The source points this out. The order you list the coordinates matters. Arrow start always refers to the first point you specify when defining the line.
Okay, that's crucial. So if I draw a line 50, 100, 150, 100, arrow start true, the arrowhead is on the left at 50, 100.
Correct.
But if I draw a line 150, 100, 50, 100, arrow start true, now the arrowhead is on the right at 150, 100, even though visually it's the same line segment.
Exactly the same line, but the start and end are conceptually swapped based on how you wrote the code.
So you really have to think about which end you consider the start when you're coding it, especially if you were directional arrows.
It's a subtle detail, but yeah, gives you that fine-grained control over direction.
All right, learner, let's wrap up this deep dive on arcs and arrows. Quick summary.
Go for it.
Arcs. They're parts of ovals, defined by the oval center, width, height, plus that start angle, 0 degrees up, clockwise, and sweep angle, how much arc.
And for circular arcs, remember, width and height must equal the diameter.
Right. And arrows. They're just lines.
Lines with optional heads. Arrow start true, arrow end true.
But remember, the order of coordinates dictates where start and end actually are.
Definitely. Key takeaway there.
So the best way to really get this is just try it out. Seriously, learner. Open up your Python environment.
Experiment.
Yeah.
Play around with the numbers.
Yeah, change the center, the width, the height for arcs. Mess with start angle and sweep angle. See what happens. Draw some lines. Add arrow start, arrow end. Swap the coordinate order.
Seeing the code change the visual output directly, that's how it sticks.
Absolutely.
Which leads us maybe to a final thought for you, learner. Now that you know how to make these individual shapes, arcs, and arrows, how might you combine them?
Ooh, good question.
Like, could you build more complex things? Maybe use arcs to make, I don't know, parts of a pie chart or those gauge needles on a dashboard?
Yeah, or use arrows to show connections in a diagram, or maybe the path something will follow in an animation.
Exactly. Combining multiple arcs, multiple lines with arrows. How could that help you build more interesting visuals in your projects? Something to think about.